So just like with the regression example, um, these machine learning algorithms really work best if your data is normalized, okay? And what the algorithms are really looking for is training data that's normalized so that it has a mean or an average value of 0 and a standard deviation of 1. And scikit-learn comes with really useful pre-processing normalization functions to accomplish this goal. So the first thing I need to do is set up a parameter that is going to contain my information for how my data is scaled. Then I'm going to use the pre-processing dot standard scalar function to fit the scalar to my X training data. Remember, the reason I'm generating this variable is because I want to normalize this data set for training, but then I have this X validation set that I have to normalize in the exact same way to get consistent results. And then I'm going to create a new variable called xtrain scaled and apply that scalar using the transform function to my X training data set. So now I have this scaled version of my training data set I can feed into the machine learning algorithm. So the next thing I want to do before I actually start to train my machine learning algorithm is I want to actually plot out what this data set looks like. And this is really important that you do this, that you don't just start to feed whatever data into a machine learning model. You want to visualize it first and try to understand whether a machine learning approach is even appropriate, right? Because if the data is really random, the machine learning is not going to have some magic way to start to classify your data. You want to make sure that to plot it out and see if the data looks like it has separate clusters or categories. Okay, so for that I'm going to use the pyplot library, and I'm not going to get too much into this. I'm just going to show you how to do like these standard plots so you can analyze your data. You can get more documentation for pyplot online. It's a really simple library just for making graphics in Python. So first I need to specify the figure I'm going to use. This is the actual window that will pop up that has my plot. And then I'm going to call up the pyplot library. So here I've imported as plt, plt.scatter. And here, this is the function that will create the scatter plot. I need to give it the x and y parameters. And the x and y parameters of my plot should be the two features that I'm using in my data, right? So on the x-axis will be the count of the words from OCT that are found in each comment, and the y-axis will be the count of words from outside OCT that are found in each comment. Okay, so I'm going to feed in that data, and it's in my xtrain scaled. I'm going to use the scaled training set. And to access just the first parameter, I'm going to use this NumPy notation, which for each dimension specifies which data you want. The colon is all the data in the row dimension, so this is all instances, and then comma in the second dimension, which is the columns, I want just the first piece of data. So this will be my first feature. I'm going to put comma, copy that, and now I'm going to specify the second feature. So this will be x-axis, my first feature, y-axis, my second feature, and then I'm going to say c equals my y training data. And c is a parameter that you pass to your plot. It tells you where to get the color for each point in your scatter plot. And the color is going to come from the value of the y training set. Okay, if it's 1 in OCT, it's going to give it a red color. If it's -1 in outside OCT, it's going to give it a blue color. Okay, and this is just a way to visualize our data and see if there's really a difference between comments that come from OCT and not, in terms of the features we're going to use. Okay, because this is what we're going to give to our machine learning algorithm to try to train this model. And finally, I need to tell pyplot to actually show that figure. Okay, so this is all the code sort of for the Python plotting library. We specify a figure, we tell it what kind of plot we want, and then we show that figure. It's pretty simple. I'm going to run this. Okay, and we should pop up this figure 1 plot. And here you can see all our red dots are comments that came from OCT. And then the x-axis is the count normalized of the number of words from the in OCT word data set that each of those contain. And here's the same for outside OCT, and this y-axis is the number of words from outside OCT. So you can see this distribution where in the middle, where there's just not a lot of words being counted, it's sort of mixed up, right? There's some blue, there's some red dots. As you go along this axis, the comments that contained a lot of the words from OCT are always red, which we expect. And the comments that contained a lot of words from outside OCT are always blue, which we also expect. So we see here is this kind of distribution where you don't have a clear division, but you have some kind of trend, that there are some similarities between the red ones and the blue ones. So when we do this classification, the algorithm is basically going to give us the best segmentation of the space. It's not going to get every comment right? Because it says we'll break the 2 categories here. Some reds are going to be classified as blue, and some blues are classified as red. But it's going to give us a pretty good model, right? Something better than random that we can use. Okay, so that's really the point of this plot, is just to visualize or explore our data to see if it makes sense to apply a machine learning process.